Okay, I think I'm just going to go ahead and get started. I mean, we'll start with a small introduction anyway, so I don't think it's too bad if some people join later anymore. So yeah, very nice to meet you all. I hope you've been having a lovely time at the online part of the UbiOps conference. And if you happen to be in Toronto tomorrow physically, I really look forward to meeting you in person as well. But yeah, I am Anouk. I work as a product owner at UbiOps, which is a Dutch company. I have a background in nanobiology and computer science and some experience as a data scientist. And yeah, currently I basically oversee the roadmap at UbiOps and what kind of features we should be incorporating. I will talk a little bit about what UbiOps is and what it does to kind of put my talk also in the context of like my background. But yeah, basically the schedule I have for this talk is just short introduction of like what UbiOps actually is, framing the downtime problem, like how I personally look at it, especially in an MLOps context, and how we at UbiOps approached zero downtime. So you can basically see this talk a bit as a kind of a case study of how we approach this problem and how we tackled it. And I hope that that can be useful for your own situations as well, and hopefully applicable to your own setups as well. And I'll end with our approach in action, just to show like how it actually then looks like, what I'm going to be talking about. So first conceptually and technically, and then I'll just show you how it actually works and how it looks. And of course, there's more than enough time at the end for a bit of a Q&A. As said, pop any questions you have in the chat. I will get to them at the end because I can't see the chat as I'm presenting, but definitely pop them in and I will try to answer each one at the end. So starting with what we actually do at UbiOps, because you see this random logo whacked on here, and maybe tomorrow you'll see us at the booth, but perhaps you have no clue who we actually are. Basically, what we focus on is getting machine learning from the lab to the field. And with that, we kind of mean getting it from a local computer to a place where it can actually start bringing value for a business. So very MLOps, of course. Often we still get the questions from companies. I think probably most of you won't wonder about this anymore, but we still get this question a lot about what is actually the issue with just running a local Python script. I mean, it works fine. Why would I change that? Main things, of course, security. A laptop might be stolen or hacked, and who has actually access to this laptop? Data. Often a laptop only has access to a certain subset of the data that a model can be trained with, but definitely not the production database. Or even if it's very sensitive data, you might only be able to access it from certain virtual access point, and you cannot have it physically on your laptop. Reliability, a laptop might crash. It might not be running 24/7. And what if you have some kind of model that is near real time, that is running like every minute of every day? That would mean that you won't be able to use your laptop for that time. And that's the nice thing of putting something in the cloud, where you can use these cloud resources without having to sacrifice your own laptop capacity, basically, and just shooting off those jobs, having them run and getting the results back. Resources, does a laptop have enough compute power or memory? Maybe if you're running like a super heavy neural network, that doesn't really work on your laptop anymore because your GPU is maybe not powerful enough. Scalability, maybe if you need to run the script once a month, that's fine. But what about if you have 100 requests coming in per second continuously? Will it then also still be fine? And maintenance. So, well, I mean, most companies will at some point kind of realize like, okay, you know what, maybe we should get a plan for actually getting it in the cloud somewhere. And often it looks a bit like this, like we'll just set up some kind of Jupyter lab environment. We put everything inside a Docker container and we just magically put that up in the cloud, and then we're there, right? And I think all of you who have worked with MLOps might have figured out that by now that this is actually a very wobbly road, and that there are tons of different services coming together. You have your version control, your database systems, Docker containers, Kubernetes for scaling and whatnot. So all of these things are coming together, and often it becomes quite a puzzle to actually get your setup right and get it working for your use cases. Well, that's something we also experienced firsthand. We started as a data science consultancy company, and every time we had to deploy our models at our clients, and we figured out, God, this is such a hassle to do. We got to make this easier. And just out of this internal frustration, we wanted to get to kind of something like this, where we could just put UbiOps in between and have it that way. So that's where we came from. So I'll skip this for now because I'll get to it later. But basically what UbiOps is a deployment and serving platform that we have. We Dockerize your code, we scale it with Kubernetes, and we make sure that everything has its own API endpoint that you can call so that you can start connecting it with whatever services you have. And that there's like this stable consensus of how your code needs to be called from anywhere. So that's basically what we do. Just as some context of why I'm actually standing here, because zero downtime is very important to us because we are a deployment and serving tool. So our customers, our users are very dependent on us making sure that there's no downtime when they're working with their models, and that they can make sure that they meet their SLAs with their customers, etc. So this is really something that's very core to us, and we've experimented with it a lot to try and like optimize our setup. So I just want to walk you through how we did it. But let's first start with actual like what is zero downtime in an MLOps context, because it's a bit different than in a software context. At least that's what I think. So there are a lot of definitions out there, but mainly like this is the one I really like from CraftQuest, I believe it is. They said zero downtime deployment is a deployment method where your website or application is never down or in an unstable state during the entire deployment process. So whenever you're updating, whenever you're deploying, it needs to be stable and usable throughout the entire process. And this is something that's very thoroughly explored in DevOps and in general, like software engineering. There are lots of different patterns and paradigms for how to cope with downtime during deployment and how you can mitigate this. Certain patterns include the rolling update deployment pattern, where basically if you look at your piece of software in terms of different services, or you have like a microservices architecture, that you update each single microservice one at a time. So at every given point, there's only one of these services that's down, and while the rest of your software will continue to work, but that still has some downtime. Another option is a blue-green deployment pattern. This really takes out the entire downtime. If you're not familiar with blue-green deployment patterns, this is basically where you keep your previous version alive and up and running, while in parallel you deploy your new version. So you just have, at some point, once the other one is finished deploying, you basically have two versions that do the same tasks, that are both online. And only once that second version is fully ready to function, to take over, then you shut down the previous version. So with that, you never have any downtime, because while the other one is still in the process of deploying, you can use the old version still. Best effort controlled rollout and ramped slow rollout, and there are tons of these. If you do a quick Google search, there will be lists and lists and lists of different patterns that you can use in like general DevOps. But I think when you put it inside an MLOps context, the issue is maybe a bit more two-sided than just downtime during deployment. So when we go back to like this definition where an application is never down or unstable during the deployment process, I think when you put that in an MLOps context, it becomes a little bit different, because you all of a sudden have a two-sided problem. So you indeed have this expected downtime that you can mitigate, where it's related to deploying. So whenever you're updating your models or databases or whatever, that's the same as with general software applications. However, on the other side, you all of a sudden have a big chunk of unexpected downtime, where your models can start to fail unexpectedly, maybe because of unexpected changes in data. I think things like data drift, concept drift, those kind of things. And those are really MLOps specific, because when you put software engineering and MLOps kind of side by side, MLOps and data science in general is very volatile, because the data is very volatile. You all of a sudden have this big variable in your equation, which is the incoming data, and everything you made is dependent on this data that's coming in. So if something changes there because of something that you didn't figure would happen, so maybe you're using certain sensors to measure some data that's being forwarded to your model, and these sensors might be changed for a newer model, and you weren't aware of that, and then all of a sudden the data that's coming in is very differently formatted, for instance. And that's a big problem because that can cause your model to just stop working all of a sudden when you didn't, like there's no blue-green pattern that you can put in to kind of catch this. So let's look at these two in a bit more detail. So we basically have downtime when updating your models, which is the expected downtime or the downtime that you can control. And you have the downtime when of models that fail unexpectedly, that all of a sudden cannot handle a certain input. So when you look at downtime when updating models, this might sound like a very minor inconvenience. I mean, it's similar as in general software dev. Like who cares if it's down for a minute? Like that's fine. But the thing is that data science is very iterative in nature, and especially also once you start putting them in production. I mean, I probably don't even need to explain this to you, but I basically took here like the data science life cycle, and you're continuously like looping through this. So you're continuously going from data collection to model creation, model optimization, deploying it, using it, and monitoring it. And then at some point you will figure out, oh, it's not working as I wanted anymore, or the performance is down, or I see that the data is shifting, and you start again. So you go again through this loop because you need to retrain, update, continuously iterate to make sure that you always have the best model in production. And these cycles are much shorter in an MLOps context than they are in a general software context. Normally, you don't need to continuously overhaul your entire piece of software, your entire application when a user entered a number that you hadn't accounted for or something. But in MLOps, you continuously have to iterate through this. And it's imperative that you do so, because if you do not, you might end up with models that start failing because you didn't retrain in time, because your data started shifting or whatever. So it's important that you can also make these cycles quickly. And when you have a lot of downtime, whenever you update your models, then that means that you're going to postpone updating your models when you actually need to update them. So what happens, and we actually see this a lot, is that companies are like, okay, I've got this great data science team. I'm going to make amazing models, and I'm going to make sure that everything ends up in the cloud. And then it's deployed somewhere. But it was very rushed, and this setup is actually not capable of supporting continuous updates. So what happens then? So then at least what we see is that they have this model in production, that model starts failing after maybe a month. And then it's like, oh, how do we actually get the new one in there? And then they need to retrain, etc. And then by the time they actually have updated that model in production, they've had this extended period of time where their service was down, basically, just because it took too long to even update it. And that's kind of the risk of when you don't, when you have too much downtime when updating your models, even if it's just a little bit, even if it's like an hour, if it's an hour every time, that starts stacking up, and that might cause you to actually delay updating your models, which then in turn leads to faulty models in production, which leads to even more downtime. So it's kind of like this snowball effect that I think is very important to mitigate, and to think about this before you push your models in production. So yeah, this I basically already said. And maybe something important to mention here is that this, like at least a use case that we see a lot for our users, is that our users have certain models that they basically sell to their end customers again. So they are dependent on their models being up and running continuously, because they will make certain service level agreements with their end users about downtime and about how long a request might maximally take and how often it can fail, etc. And if they need to adhere to these SLAs, then also their systems need to continuously be up and running. And it's important that downtime is mitigated wherever possible, because otherwise they cannot meet those SLAs anymore. And yeah, as I said, like this happens very often, at least that's what we see, like model maintenance is often an afterthought. So if you can take anything away from my presentation, please let it be to think about your setup and about how you're going to actually work with your models once they are in production. Once you've gone over that step, like how are you going to make sure that they continue running smoothly? Then the other side we had was downtime due to failing models, so that fail unexpectedly. There are many reasons why this can happen, and this is just because machine learning is very unpredictable. Data can change continuously. Data is very volatile. So this is definitely part of downtime where you have much less control over. Something that I see as like a common practice to kind of mitigate the risks of downtime due to unexpectedly failing models is to set up kind of like champion challenger pipelines. So where you're running two versions of a model that perform the same task, where you're running them in parallel. And whenever your champion model, like your main model, whenever that fails for whatever reason, that then the request or the data is rerouted to the challenger. And then this challenger can kind of act as like this backup model, and maybe that challenger will be fine and will be able to handle this. And then in that way you can mitigate this. Of course, if your challenger also cannot handle the incoming request, then you will still have to deal with the downtime resulting from these models, but it can definitely help to mitigate some things. Maybe to give like an example of where this could be handy is, maybe you have in your champion model, you have a certain dependency, maybe a certain Python library that you're using, and you haven't picked the version. So you always just take the most recent version of that library. What can happen is when they deprecate something in the library that you're using in your model, this can lead to your model all of a sudden not working anymore, just because the library got updated somewhere down in your dependency chain. And then your model can fail. But if your other model, your challenger, does not use that library, that one should be able to handle it. So then you don't have to have this downtime. So that's like scenarios where this can be handy, where you have unexpected like dependency changes, for instance. Okay, so that's it about how I look at the downtime problem in general in an MLOps context. So I want to walk you guys through how we tackle zero downtime for models and like what we try to incorporate in our platform to kind of mitigate downtime as much as we can. I'll first go through it conceptually, and then I'll shortly take you through one of our architecture diagrams, or a very simplified version of it, just to see what's kind of happening under the hood. But on a conceptual level, UbiOps works with this concept that we call deployments. Deployments are anything that has an input that is transformed into an output, very simply said. So that can be a machine learning model, pre-processing steps, algorithms, whatever, something that takes certain input and has a certain output. Now, each deployment can have multiple different deployment versions that are under that. And these deployment versions are the actual implementations in terms of code of the deployment. So they all have the same input fields coming in, like the same structured input data and the same structured output data, but the code that's in between that actually transformed input to output can differ between each version. And each version can also have different settings like memory allocation, GPU, CPU, if it's Python or R, those kind of things. But basically these deployment versions are an implementation of the deployment. And then under each deployment version, you have something that we call revisions. So in case you don't want to make another version in UbiOps, but you just want to overwrite a version, that's also possible. If you overwrite a version, we will just create a new revision so that there's still like a log of what happened, especially for like auditing stuff. So revisions are like different code versions of each deployment version. So we have deployments, deployment versions, revisions. And then one thing that we added in there as well is that each deployment version can be marked, or that one deployment version per deployment can be marked as the default version. And this is because every deployment version in UbiOps gets its own API endpoint, is exposed via its own API endpoint that you can call. However, if you're using your model in production and you have all of these other services calling your model, maybe like a website that's calling the API endpoint of your model, you don't want to have to update that API endpoint whenever you update your model. I mean, that would mean that then even though you have no downtime when updating it in UbiOps, that you still have downtime in your other services because you need to change your API endpoint, like the endpoint URL. So what we did there by introducing this default endpoint is that you can mark one as a default per deployment. And because of this, you can use a generic API endpoint for your deployment. So that's always the same. Regardless of which version is your default, that endpoint URL will always be the same. So you can use that endpoint URL in your other services. And let's say we mark like version 1 as our default, then whenever you make a call to that endpoint, that version 1 will actually be the one that will handle that request. And if you want to change your version that you're using, then you can deploy that new version, create that new deployment version. And once that's up and running and you're happy with how it works, then you can switch the default to that one. And by switching that default, that doesn't introduce any downtime because it's just a parameter of the deployment. So your endpoint URL stays the same, like everything from your surrounding infrastructure that's using your deployment will just stay the same. The only thing that changes is what's actually behind that endpoint. So this is something that we did to try and like mitigate the downtime here. And whenever you make a revision, that's maybe also good to point out, like you don't want any downtime when you're overwriting your version. So let's say I'm using like this default version here, and for whatever reason, I decide to overwrite that one, then I don't want any downtime while the new one is building, because whenever you create a new version in UbiOps, it first needs to like build the Docker image, install everything, get it up and running, etc. So what we did there is that whenever you create a new revision, then the old revision will remain available right up until the moment the next one is fully ready to take over. So this way, even when a user will make a request or a call to your default deployment while you're in the process of overwriting that one, it will still be able to return a result because it will just use the previous version right up until the point that you're ready for the next one. So this is kind of conceptually like how we looked at this. So yeah, every deployment points to a default version. Which version is the default is just registered in the deployment details, and changing this default simply updates the parameter. And our API only needs to know what deployment you want to use, and then it's all good to go. So then technically, how does that look? How does it work? So let me walk you through this. So on the left here, we have a user. A user makes a request to our API or to the your API endpoint of your model. Then our API will register that request inside a Redis queue. That's what we're using in the back. And at the same time, it will also check if that deployment that you're trying to make a call to is actually available, and if there's already an instance spun up from that deployment that can actually handle the call. If not, it will spin one up and make sure that it's ready with the correct settings that you defined. So we have it saved in the Redis queue, and we're checking if we have an instance up and running. Then we have our router microservice, and this router is continuously polling our Redis queue to see if there's any work that needs to be handled. So whenever there's a new request coming into this Redis queue, the router will look at this request, check which deployment it needs to go to, and send it off to that deployment instance to actually be handled. So this instance will start processing, running your code, doing whatever it needs to do. And once it's done, it will register it results in the API and tell the API like, hey, look, I've finished my job. This is the result. And once the API receives that, the API returns this back to the user to give the result. So this is like our technical setup of what happens whenever a user makes a request. Of course, I left some things out like Docker and Kubernetes, but basically this is the flow. This is the structure. So that's happening. And what did I want to say? Yeah, so if in the middle of your user making a request, you are updating one of your versions, or you changed, let's say you overwrote a version, you made a new revision, then what will happen technically is that these old instances that were already spun up from the previous version will just continue to be alive. They will thus get the jobs from the router that came in, right up until the point that your instance is fully ready. So whenever your new revision is ready and validated by the API, and the API is like, okay, you know what, this one works, then our API will send out a call to terminate all these deployment instances from the previous one and spin up a new one. And it will only terminate these once the new one has been spun up. So because of that, there's kind of like this clean cut where all the old instances can be used right up until the point that the next one is ready. So again, this is kind of like a blue-green setup to make sure that the jobs can be handled even when a user makes a request in the middle of you updating something. And in case you change the default version, then basically that changes this step 3 only, because then the API gets like this gets this general API call to a deployment, not specifying which version. Then what the API does is the API checks, okay, which is the default of this deployment, and then it checks after that if there's an instance available for that default version. So whenever your default is updated, just this step will change, because instead of checking maybe if V1 has an instance available, it will now check if V2 has an instance available. So that's not something you notice anything of as a user, because in the background it's just handled like that. Yeah, so that's what I said. Okay, so that's kind of how it works for like how these concepts actually work in the background. Then something else I wanted to shortly touch upon are versions in pipelines. Something that we offer are pipelines. This is basically, yeah, sometimes you don't have a single model or a single piece of code you want to call, but you have many different steps that are kind of like tied together. So maybe you have like something that collects data from a database, and then after that, the data needs to be pre-processed, and the data needs to be sent on to the model, et cetera, and you have like all these different steps in there. So if you want to update your pipeline, you of course also don't want any downtime. And basically how we handled this is that each object in a pipeline references a deployment in the background. So this is not some kind of like new instance or new thing. It just references whatever deployment you set it to reference. So you can, I also took a little screenshot so you can see it here, that this block, if I check the details of that, I can see that it's referencing this deployment that's called like predictor, and that has version LSTM 1 epoch. That's what it's referencing. So if it happens that I want to change whatever version is used in a pipeline, I only need to update the reference and nothing else, because all the downtime is then, or like the transitions and the deployment, that's all handled via the actual deployment process. And the pipeline doesn't have anything to do with this. It's just simply changing whatever deployment it's referencing to. So as long as your version is actually available once you change the reference, that's all good. And because of that, this setup allows for running different versions in parallel and swapping them if necessary. So basically to create one of the champion challenger pipelines to mitigate this other side of downtime. So you could have just your champion and your challenger running in parallel, processing each request, but only the champion is, for instance, connected here to pipeline end. So that's the one that actually gives the result back to the user. So the user won't see the result of the challenger unless we figure out that our challenger is overperforming our champion. Then we can swap the two out and make sure that we have the most optimal pipeline that we can, because it's basically just changing references, and these references can also be changed automatically through code. You don't have to do that manually. Okay, then yeah, benefits of such a system, basically it allows for like a soft rollout of your new versions. There's no downtime whenever you're updating your model, and because of that, you can really keep these iterative cycles of data science where you can just update it whenever you need it, because there are no downsides when you're updating it. You can just freely do that, freely experiment, and there won't be any downtime related to that. And no need to update the endpoints that you use in the rest of your stack, so that you also don't need to make any changes in the rest of your stack whenever you decide to update a model or switch to a new version. Okay, I'll shortly have a look at the chat before I go to our setup in action, because I just want to show you like what I'm actually talking about, which hopefully will give a bit of more context. So let me look at the chat shortly. Okay, that's all good. Then we'll get back here. Okay, so this is the UbiOps web app. There are, of course, multiple ways of interfacing with UbiOps, but I figured this was a bit, the easiest to follow because it's just visual. So I've got my deployments here, and when I go to them, like you can see this one has like 2 different versions, and you can see that this one is marked the default. If I want, I can just change this one to the default. And now that one will receive the request, or I can just change it back to this one. Or let's keep v1 the default. When I go to one of those, I can also check the revisions. Like I recently revised this one, so you can check which revisions are there, which is the active version. Actually, also download that code to see that. So this is just a dummy deployment. It doesn't do anything magically. It just multiplies a number by 2. Closer shortly, we'll need to start up. And what I want to show you is I wrote a little script that basically sends a bunch of requests to the default endpoint of this deployment. And halfway, I'm going to switch which deployment is actually default. So then halfway, it will switch from v1 to v2. And I just want to show you that in the request, you don't actually like notice that because it just goes from one to the next. So like, here we see like this is just what it does. It just takes this input number, multiplies it by 2. Okay, so if I now go to this one, so I've got here a little notebook. Just run this cell. I'm using the UbiOps client library here, which is just our Python client library, which allows you to like interact with the UbiOps API a bit more easily through Python code. I'm just authenticating with an API token I can create in the web app. I need to provide my project name, the deployment, and I have here the names of my 2 versions, so v1 and v2. I just connected to it. It says status OK, so that's all good. Then I'll quickly test out just doing a request to v1 and v2. Well, v1 is already warm, so that one's already ready to give my response back. So that worked. And then I'll shortly wait for the next one to also continue speeding up. Yeah, okay, so that one also worked. And currently our default version is v1. And what I have here is just very simple, basic for loop where I make 100 requests. And once I'm at the like halfway, I will switch the default version. So I'm just making an API call here to change the default version to the new deployment version, which is this v2. That's what I have. So if I run this, and then after that, I will just make a quick plot of the request duration. Then you will hopefully see that just each request was handled and that there was no problem halfway where the endpoint was not callable. So if we now also go to the web app, we should be able to see everything incoming. If we go to the monitoring tab, we have here a request overview, and we just see that they're coming in, and I can check them. This was request number 90, so it should almost be there. Then, yeah, so that one's done. I think import it shortly. And there we go. So if we have this plot, we just see like some random variation for how long the request took, just because you always have a little bit, but there's no, like at this point, this is exactly where we switched the defaults, and you can just see that each of these was just handled. Maybe the first version was a bit better than the second version in terms of how long it took to take care of the request, but you can see that each request is still handled even though I switched them out like halfway. So yeah, that's basically all I wanted to say and show. So I'll stop sharing my screen, or oh no, wait, I'll share it still a little bit for the last slide with our contact information. There you go. Yeah, so first of all, thank you very much. If you want to know more, head over to our website. You can email me at this address or just send me a message. Or if you happen to be in Toronto, feel free to, of course, drop by our booth tomorrow or talk to us tonight at the MLOps Community Happy Hour at the Prenup Pub at 5:30, if I'm not mistaken. You can also always try it out yourself with a free account. And that's all from me. So if you have any questions, please shoot, and I'll do my best to answer them. Was it a bit clear? Like how our setup is, or any more information that you will want to know about what we do in the background? If not, then thank you a lot for listening in and joining. And yeah, as said, if you have any questions still, drop them in there. And definitely pass by and have a very nice day. So at the rest of the conference. We do not have an open source version at the moment, but we do have just a free version that you can use. And that free version, I think, stays valid for a year, where you can use all the functionalities that are in there. The only thing that's limited is the amount of compute that you can use. So, and GPU support is something that's not in the free version. But other than that, all the same features are also in the free version. So you can always test it out, but it's not open source, no. Yes, you can create a deployment just through the UI. I can actually show that if you want. That might be the easiest. That will give you some context. Let me share my screen. Okay. There we go. So this is the web app again. Let's say I want to create a new deployment, and what I need to do is give it a name. So a random name. There we go. Can give it a description. I don't need that. So I need to define what kind of input and output is happening. It's coming in. I can also select plain. That's just any type of string. But if I do structure, let's say I have like an input number, which is an integer. Okay, we can select the data types and some kind of output number that I have, which is also an integer. Then I'll get this little code template that's pre-filled in and like pre-formatted. And there's indicated like where you can actually put your code. So I could download this and change that up. And then after that, I can go to create a version. So if I would want to check this out, I could just open whatever editor I have. We don't have an editor in our web app. If that's what you're looking for, that's not what we do. But you can just open it in any IDE of your choice. So if I go, save file, open folder. Yeah, here I have the deployment package that was generated by the UI. I can open that one if Visual Studio Code wants to help out. Yeah, there we go. So we get this deployment package in here. It's a different one, the one that I opened, but it's still pretty much the same. So we can have input number, and we had output number that we needed to return. So yeah, at the place where we have our code, we can just multiply it by 2. So output number is input number times 2. It's very simple, but so you get the idea. And then we just need to return that in here. Output number. And then if we zip this up, we can shoot it straight back to UbiOps. This is, of course, a very simple version. If you have anything that's very special or that needs other things, like you can include anything you want inside the deployment package as long as this deployment API is there. Requirements.txt for any dependencies you have. And we also have support for OS level packages and whatnot, but I won't go into that right now. So you could zip this up and then you can upload it up here. And then, so I could get it from there and then check which language it is. And if you want, you can also have a look at all the advanced settings, but it won't be necessary. And if I click create, it would start creating, but I think I selected the wrong one. But that's basically the flow in the UI. And anything you do, you can do in the UI, you can also do with the Python client library or with the CLI. So that's how that works. I hope that gives a bit of clarification. Does that answer your question, Karamfir? I hope I pronounced your name right. Cool. Any other questions? Okay, then have a very nice day.